The next is benzaldehyde. So benzene ring with C double bond O H, and here it is benzyl carbocation. So CH2 with one positive charge, and the resonance takes place as we have discussed in phenol, or we can say benzyl carbocation, right? And this is again but2-ene 1-yle. That was al, and here it is yle. That means double bond and it goes to the CH2. So here only one resonance is possible, right? The next question is, what are electrophiles and nucleophiles? Explain with examples. Again, we have discussed this electrophile and nucleophile, right? Species which are electron loving, species which are nucleus loving, right? If they are nucleus loving, that means they are negatively charged, then and only then they are going towards the nucleus positive, and electrophiles, that means they are positive, then and only then they are going towards electrons. So the name electrophiles means electron loving. Electrophiles are electron deficient, means they will accept the electrons to form covalent bond. Electrophiles are electrodeficient, that means they want electrons, and so they will accept electron pair to form covalent bonds. They may be positive ions or neutral molecules. These are all positive ions, and 1, 2, 3, these are the neutral molecules. And nucleophiles, the name nucleophile means nucleus loving. It indicates that it attacks the region of low electron density. Low electron density, that means those who are carrying positive charge in a substrate molecule. They are electron rich. They may be negative ions or neutral molecules. They can share an electron pair. Please remember this thing. Nucleophiles can share electron pair to form covalent bond with atoms other than hydrogen atom. That means if nucleophiles are sharing electron pair with hydrogen, then they are not nucleophilic species. But if the electron pair are shared to the atoms other than hydrogen for formation of covalent bond, then they are the nucleophiles. So here are the examples: Cl minus, Br minus, Cn minus, H2O, ROH, SH minus. These are all nucleophiles. Now here is the question which is not in the textbook exercise, which is extra question, because such type of questions are sometimes asked in the competitive exams. Electrophile. Are H3O plus and NH4 plus electrophile? So here what happens? H3O plus, right? So H3O plus will never accept electron directly. Why it will never accept? Because it is not having any empty p orbital. So it will not accept electron. It is having positive charge. So positive should attract electron, but because of the reason that not having empty orbital, p orbital, it is not directly accepting electron. So what takes place? So let us see the structure. O, H, 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 that is H3O. Now looking to this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. It is already complete because it has 4 bonds, so 8 electrons. But it has positive charge. So what happens? It can accept electrons. Positive can attract negative electrons. But here it will not accept. Why it will not accept? Because already it has completed its octet, right? And it is not having now d orbital, that more electron can be arranged. So what it will do? It will, here I told, it will not directly accept. So what it will do? It will disperse into H2O plus H, and thus this H will take the positive charge. So it will be done by H plus. What will be done by H plus? Acception of the electron. Accepting of the electron will be done by H plus. For it, H3O plus will dissociate into H2O and H plus, and then H plus will accept the electron pair, and thus H3O plus is electrophile because H plus dissociated from it is accepting electron. Directly it is not the electrophile. In the same way for NH4 plus, see the structure, NH4 plus acquiring positive charge. So here also 4 bond, so octet is complete. Means though it has positive charge, it will not accept electrons. It will also dissociate NH3 plus H plus, and this H plus is accepting the electrons, and that is why it is electrophile. So this is the special case for HCO plus and NH4 plus. One more example is over here, acetone, CH3, C double bond O, CH3, that is propanol, common name is acetone. So in acetone what takes place, this bond is giving electrons to the oxygen, or we can say oxygen is dragging the electrons, being more electronegative than carbon. So it will acquire now negative charge because accepted the electrons, and at the same time carbon, now see 1, 2 and 3 is not satisfying the valency. That means it is already giving the electron, so it will be positive charge. So here carbon atom is electron deficient, it wants electron, so it will accept the electrons and it is electrophile. And O negative can attract any other hydrogen. If hydrogen atoms attacks here, then O negative can attract hydrogen ion and it can convert to alcohol group. Right? In the similar way, even nucleophile question is also there, that OH minus. If we say OH minus, then it is the basic component which is considered as base. Right? H plus acid, OH minus base. So here the question is NaOH plus nucleophile or basic? So let us see here OH minus, when it is attacked by H plus, so definitely this minus charge will attacked by positive charge and it will give H2O. Here OH minus share electrons with H plus. See, just now in the definition I told that, remember this thing, when a species is sharing electron with hydrogen, then it is not nucleophile. If it is sharing electron pair or electron other than hydrogen, to nitrogen, oxygen, sulfur, right, any of the other element or atom other than hydrogen, then it is nucleophile. So here OH minus is not nucleophile because it is making the bond with hydrogen. So OH minus share electrons with hydrogen, so it is not nucleophile but it is a base. The next question is question 13. Identify the reagents shown in bold. Here bold, I have not made it bold, so I have written in the box. So identify the reagents shown in the box in the following equations as whether they are nucleophiles or electrophiles. So here see Ca3 COOH plus OH minus. Now we have to see whether OH minus is nucleophile or electrophile. Here you see nucleophile because it is carrying negative charge. That means it is electron rich. If it is electron rich, then and only then it will love nucleus because nucleus is positive charge. That means it is nucleophile, which can be shortly abbreviated as this form. It is read as nucleophile. Here Ca3CO Ca3 plus Cn minus, right, which is giving Ca3 CCNOH. Now here what is the thing? Here Cn minus, again minus charge is there, so it is also negative charge, electron rich. That means it is also nucleophile. You have to just identify whether nucleophile or electrophile, but then also I have shown here the mechanism. So let us go through that mechanism. This electron pair will be given to oxygen, so oxygen will acquire negative charge and carbon will acquire positive charge. Now when this carbocation is attacked by Cn minus, then this minus is attacking to this positive charge because it is electron deficient and it is electron rich, right? And so as it is going towards the positive, it is nucleophile. Clear? The next is C6H5 plus CH3C plus O. Again here carbocation. So here you see positive charge. That means it is electron deficient. It wants electron. So it is electrophile. And the abbreviation is elect double semicolon and positive, which is read as electrophile. The next question is classify the following reaction in one of the reaction type which we have studied in this unit. We have studied substitution reaction, addition reaction, right? Elimination reaction, if you have remembered. So what is here? CH3, CH2, Br, HS minus, CH3, CH2, SH, Br minus. You can see here Br is substituted by SH, right? Instead of Br, now here you can see SH, and Br negative is nucleophile is substituted. So here HS minus nucleophile is substituted or is substituting Br minus nucleophile. So it is substitution, but nucleophiles are substituted. Both negative here, this negative. So it is nucleophilic substitution reaction. Here you can see CH3 2C double bond CH2 plus HCl, and it gives CH3 2. This remains same, CH3 2, that is twice. C double bond is now broken over here, cleavage has taken place, and with C, Cl is there, and this CH2 is now CH3. So definitely we can see that Cl is added to this compound. That means compound is 1, but Cl is added to this carbon and hydrogen is added to this carbon. It means this is definitely a addition reaction. Here on cleavage of HCl, it is added in the reaction as H to CH2 and becomes CH3, and C double bond is now single because valency is balanced, and Cl to CH3 twice C and becomes CH3 to CCl. So it is electrophilic addition reaction. Why it is electrophilic addition reaction? Because when HCl will cleave, then H plus and Cl minus will take place, and actually here H plus is also there, Cl minus is also there. So H plus is positive electrophile and Cl minus is negative nucleophile, but H plus being the H positive is being the member of the acidic family, its reference is given more. So it is electrophilic addition reaction. About this you will learn more in 12th standard. So if you are not mentioning all this, no problem, you must know whether it is addition reaction, substitution reaction. The next is CH3 CH2 Br OH minus, and here it is CH2 double bond CH2 plus H2O plus Br minus. Here what happens? Here CH2, that means this CH3 is mentioned over here, CH2H plus CH2Br and OH minus. Now what takes place? These OH minus, it will try to attack to this H plus, right? And it will be dehydrated out as H2O. And this CH2 is giving this bond to Br and it will be also taken out. So what will happen over here? As soon as this OH minus is attacking to this H, it will take a positive charge by donating its electron here, and here it will be double bond now. So it is CH2 double bond CH2. H2 as a dehydration takes place and Br minus is also taken out. That means elimination takes place. But here elimination of two things takes place, hydrogen as well as bromine. So here H and Br both are eliminated, right, from main reactant. So it is bi-molecule elimination reaction. And one more is CH3 thrice C CH2OH plus HBr, CH3 2 CBr, CH2 CH3 plus H2O. So what type of reaction is this? We are supposed to understand. So here see the structure, C, CH3, 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 that means CH3 thrice, CH2OH having two lone pairs, and the attachment is HBr. So again this is acidic bromic acid, so H plus and Br minus. So this H plus will be attacked by the electron pair here, positive, and electron pair negative, right? So what will take place? CH3 thrice, CH2, and here now H will be also linked with it, so it is H2O, right, where it will be the charge over here, right? What happens now? This H2O with O positive remains unstable, and so it will be dehydrated. It means it will remove this unstable portion, that is H2O is removed, dehydrated. So now what takes place? CH3, 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 and now this CH2 with positive charge. So here shifting will take place. This methyl group from this first carbon will try to shift here. So it is 1,2 methyl shift, and this positive charge will be now here as a carbocation. 1 degree carbocation is here. Now it will be taking here place. So it will be on 3 sides. So here 3 degree. See, CH3, CH3, CH2, and this is CH3 here. So it is 3 degree carbocation. Clear? And here the same thing takes place. Now this Br, right, it will take place over here. So what happened over here? Br is attached to CH3, CH3, CH2 and CH3. So actually what you have seen, here the rearrangement takes place. Once it is shifted, then again rearrangement has taken place. So we can say rearrangement reaction also. Also nucleophile, that is negative charge, is, what happens to it? It shifts, substitution takes place. This Br minus is substituted to the next carbon over here. So here it is substitution as well as rearrangement reaction. This is for your understanding. You are not there to write all this mechanism, right? But why I am giving that, how you will come to know that yes, it is substitution and yes, it is rearrangement. If I am telling substitution, if I am telling rearrangement, that means it should be shown over here. That is why I have shown the mechanism, right? So please go through it properly and then try to understand properly, and then only you write it out, right? Thank you.